We can use L'Hopital's rule when we have indeterminate forms 0 over 0 or infinity over infinity. When x approaches 0 from right, we will have in parentheses 2 times 0 is 0, so we have 1. And exponent is 1 over x. When x approaches 0 from right, 1 over x going to infinity. If you forgot, let me draw the graph of function 1 over x. Because in numerator we have positive number, it means we have hyperbola in first and in the third quadrant. This is x-axis, y-axis. When we approach 0 from right, we see that our graph going to positive infinity. That's why I put infinity. We cannot use now L'Hopital's rule. It means first, let me put f of x equals 1 minus 2x to power 1 over x. Now I will take natural logarithm of both sides, so we will have natural logarithm of f of x is equal natural logarithm of 1 minus 2x to power 1 over x. Now we will use properties of logarithm and we can take down this exponent, so we have 1 over x times natural logarithm of 1 minus 2x. So this is equal, we can rewrite this to natural logarithm of 1 minus 2x over x. Now we can find limit as x approaches 0 from right of natural logarithm of f of x. This is equal, we just found this, that is equal to this expression. So we have limit as x approaches 0 from right of natural logarithm of 1 minus 2x over x. Now, when x approaches 0, when we substitute x's by 0, we will have in numerator 1 minus 0 is 1. Natural logarithm of 1 is 0. And we have over 0. So when we have 0 over 0, we can use L'Hopital's rule. So it means we have to copy limit as x approaches 0 from right, and we have to find derivative of function which is in numerator and derivative of function which is in denominator. We have natural logarithm, derivative of natural logarithm of u with respect to x is equal 1 over u times du over dx. In this case, u is equal 1 minus 2x. Let me write this. So derivative of u is, derivative of constant is 0, derivative of negative 2x is negative 2. So we will have 1 over 1 minus 2x, I just use this rule, times derivative of u is negative 2, over derivative of x is 1. So this is equal, we have limit as x approaches 0 from right of, because we have division by 1, so we can write, we have 1 times negative 2 is negative 2 over 1 minus 2x. Now, when x approaches 0, let's see what we will have here. Numerator is negative 2. Denominator is 1 minus 2 times 0 is 0. So we have negative 2 over 1 is negative 2. Now we have to come back to our limit. Let me rewrite this. We have limit as x approaches 0 from right of 1 minus 2x to power 1 over x. This is equal, I just wrote, for this function I will put f of x. So we have limit as x approaches 0 from right of f of x. This is equal, I will rewrite f of x using this formula. This is equal e to power natural logarithm of f of x. So we have limit as x approaches 0 from right of e to power natural logarithm of f of x. This is equal. From properties of limit, we can write this that this is equal e to power limit as x approaches 0 from right of natural logarithm of f of x. We just found this limit. This is equal -2. Limit as x approaches 0 of natural logarithm of f of x is equal -2. So we have e to power -2. This is equal 1 over e squared. This is my solution.